So in this video, we will see what is the least element of a poset and what is the greatest element of the poset. So we know that what a minimal element and what a maximal element is. A maximal element is such an element of poset which is not related to any other element. Some other element may be related to itself. Some other element may be related to a maximal element, but a maximal element is not related to any other element. And so in the Hassie diagram, the maximal element does not have any outgoing, or you can say the upward direction. In the upward, there is no upward path from the maximal element. So P and O are the maximal element. Similarly, a minimal element is the one which may be related to other element, but no other element is related to the minimal element. So there is no incoming edge, there is no upward path to the minimal element. So A, B, G, H, and I, these are minimal elements. Now, what is greatest element? Greatest element. Okay, element X is a greatest element. X belonging to the poset is the greatest element if for all A belonging to P, A is related to P, A is related to X. Okay, means that, and we know that because poset is anti-symmetric, means that X is not related to any other element and every other element is related to X. So one thing for sure, this greatest element is a maximal element. This is a maximal element, and actually it is a unique maximal element in your poset. That is, your poset may or may not have greatest element. If your poset have greatest element, then your poset have a unique maximal element. Like in this case, for this Hassie diagram, P and O, they are maximal element, but they are not unique. Maximal element are not unique. P and O both are maximal element. So there is no greatest element in this poset. So why there has to be a unique maximal element? Let's say your poset, when you have more than one maximal element, then you cannot have a greatest element. Let's say you have two maximal element M1 and M2. Now because M1 is a maximal element, then M1 is not related to any other element. Is not related to, because M1 is a maximal element, so M1 is not related to any other element. So even M1 is not related to M2. And similarly, because M2 is a maximal element, so M2 is not related to any other element including M1. So maybe because M1 is a maximal element, maybe every other element is related to M1, but there got to be another maximal element M2 which is not related to M1. So M1 cannot be greatest element, and likewise M2 cannot be greatest element. So for your poset to have a greatest element, it must have a unique maximal element. Okay. So in this Hassie diagram, there are two maximal elements, so there is no greatest element. But let's say your Hassie diagram was something like this. Actually, E and N are also maximal elements. So, but let's say you have something like this, Z. Can you say that this Z is your maximal element? Still no, because E is not related to Z and N is not related to Z. So what we do, we make an edge from E to P. Now there's an upward path from E to Z. Similarly, I make an edge like this. Now if you see, there is only one maximal element, unique maximal element Z, and so this Z is a maximal element, unique maximal element, and greatest element of your poset. Now what is the least element? element X is the least element, X belonging to your poset. Okay, what does this P means? This P is a poset, means that a set and the partial ordering relation together. I am writing it as poset. So actually, X belongs to, it is more precise, X belongs to A. Okay, so whatever it is. So X is called the least element, S is the least element. If for all A belonging to your poset, X is related to A. X is related to A. Now, if X is related to F, then A is not related to X. So there is no element that is related to X. So definitely this least element is a minimal element. This is a minimal element. And using the same reasoning as your greatest element, that there has to be a unique minimal, there has to be unique minimal element. How? Because let's say if you have two minimal element M1 and M2, if this is a minimal element M1 and if this is a least element, then M1 is related to M2. But if M1 is related to M2, then M2 is not related to M1. If M2 is not related to M1, but M1 is related to M2, then M2 cannot be minimal element. So I am saying that if this M1 is the least element, if this M1 is the least element, and let's say M2 is a minimal element. If M1 is the least element, then this is a minimal element, and if M2 is also a minimal element, I am taking the case that let's suppose there are two minimal elements. Now, because it is the least element, then M1 is related to M2, right? But because M2 is a minimal element, this cannot be true. So our assumption was wrong. So if your poset has least element, then that least element has to be a unique minimal element. Has to be a unique minimal element. Now, in this Hasse diagram, there are many minimal elements A, B, G, H, and I. There are many minimal elements. So I will make it unique one. Okay. Let's suppose this is my Y. Now this Y is the least element. Now there is only one unique minimal element, which is Y, and this is also least element because there is a upward part to every other node. Okay, so let's end this video here with least element and greatest element. Okay, in the same diagram, I wanted to cover once again the upper bound, lower bound, and least upper bound, greatest lower bound. But
If you smell what the rock is cooking, if you smell what the rock is cooking, what the rock is cooking.